leave exponents as fractions because it does not logically make sense for what an exponent is. Everybody's okay with that? Okay, so if we have rational exponents, what do you think we can change it to? What have we been doing the past couple of days? It is a decimal. Good. What did we do yesterday, Friday, Thursday? You can look in your notes if you want. What are these called? Somebody from home, y'all can talk to me too. I got y'all up on the big screen.
Radicals.
Yes, if you have a fractional exponent, if your exponent is a fraction, you can express that as a radical. This is very new. You're probably like, what the heck? Those things are related? Are y'all with me? Okay, so let's write that down. I'm just going to scribble through that. You didn't need that. If you have fractional exponents, not whole numbers, just fractions, you can express the term as a radical. So I know I didn't write it, but we've already said it. We do not leave exponents as fractions. All right, so I'm gonna start off with an easier example and then we're gonna do the one Evan gave us, okay? So for our first example, I just wanna show you how we would change that to a radical. So maybe call this converting rational exponents to radicals. And we're gonna start off with an example. Evan, I don't like sitting down. So Evan had me when we weren't virtual last year, and I like love teaching at the board and moving around and walking around and stuff. I hate sitting. It's not good for the ADHD, but that's okay. Are y'all good if we start with a number? Is that fine? So that you guys can like actually check me. So let's do 49 raised to the half. All right, if you have 49 to the 1/2, I'm going to show you what that would be in radical form, okay? Oh my God, why did I write them 9 like that? That was so weird. I'm just showing you what you would do. I want to see if you guys recognize a pattern. So there's the first one. I'm going to show you another one, okay? What if we have 8 to the 3rd? As a radical, that can be written like this. So what do you guys see that I'm doing? Okay, your buddy, y'all are saying the same thing. Help him out. Yes. Yes, look. Okay, y'all are on the same wavelength. So the boys in class said the denominator of the exponent becomes the index of the radical. Does everybody see that? So the denominator is the index, and what did I do with the numerator? Good, I made it the fraction inside. People at home, do y'all see that?
Yes, ma'am.
Yeah.
All right, who's ready for the corniness so that you remember which one goes where? So what do you, good question. We'll do one like that in 1 second. Very good question. They asked what if the denominator is not a 1? So I'll show you. First, though, I got to make it corny, okay? So you're going to like this, Evan. Evan's like, oh my God, I don't know. Pretend you have 2 dogs, all right? And pretend these are your 2 dogs. So I'm going to zoom it in for y'all. Which dog do you think I like better, 1 or 2? Why? Because it's on the top. Good. They said 1 because it's on the top. That's your top dog. If your top dog is your better dog or your good dog, where do you think he's going to sleep? Inside with you. If your bottom dog is not your good dog, not your top dog, where's he going to sleep? Outside. Are you going to remember it now? Okay, good. Jaden's like, I like that. Okay. All right. Good dog, bad dog. You can literally call it that. I don't care. The numerator goes on the inside. The denominator becomes the index on the outside. So can we write that as like a rule so you guys have it to look back on for your test? All right. So let's just say we have x raised to the m over n. How would I write that as a radical?
The n root of xm.
Very good, Carter. X to the m. Good. So remember, the denominator is the index outside. The numerator will become the exponent inside. So there's a rule for you to look back on. On my highlighter. You can use your notes on your test Thursday. You guys will take yours in class. You'll still use your notes. Okay? All right, so what the boys in class asked, this was a really good question. So let me show y'all this one. They asked, what do you do if the numerator is not a 1? So, and can I also throw in some variables now, since we kind of know what to do? Okay. So let's do, I got some examples here. All right, here we go. I'm gonna do one of these actually. Nope, nope, nope. All right, 2x to the 2/5. All right, so you have to put what on the outside? The denominator, good. Sorry, y'all. I'm not sure what happened. I unplugged it. There we go. All right, the denominator will go on the outside, right? What would the exponent be on the inside?
2.
Good, it'd be squared. It would just be a 2. Good. Now, this is where my students always mess up on this one right here. What exponent does the 2 have? A 1. Good, Henry. The 2 has an understood 1, right? The 2/5 does not go with that 2. So if this is 2 to the 1, y'all agree that's just a whole 2, right? So do we put that in the radical? No. Good. So this would just be 2. And then what kind of root is it? 5th root. Good, Jaden. 5th root of what? X squared. Very good. So this would be the radical form. So that would be the answer. Now, they can step it up by saying simplify it. Yes, but this one wouldn't simplify. Can we take the 5th root of x squared? No, because they have to have how many to take them out? 5. Good. Yep. So do y'all see how it all ties in together? Yeah? Okay. Can we do another one? This is really all we're doing today, and then we'll get into some where we simplify. Let's see. I pulled some examples off of Delta Math that I thought were good. All right, let's do this one. VD, I'm going to step it up. Are you good, babe?
Yes.
All right. It's not too bad. I told you I didn't say something crazy for the end. All right, 5a to the negative 7/2. All right. Each one has an exponent of what? -7/2. So they're both going to have to be underneath a radical, right? Do y'all see how this is different from the first one? There's parentheses around it. What else is different about this one? It's a negative exponent. So before you can even change it to a radical, what do we have to do if it has a negative exponent?
Put an I on the outside.
Not, be careful. If there was a negative underneath the radical, we would put an I on the outside. Good review. What if there's a negative exponent? There's a reason I do this lesson last. It ties everything in this unit together. What do we do with negative exponents? Yes. Good. All three of you, good job. You flip it to the other side of the division bar, right? Do you guys remember writing it like this?
Yeah.
Yeah, this was like almost 2 weeks ago. Can you believe that? That was crazy. So 1 over 5a to the 7/2. Okay, and now what can we do? Because we can't leave 5a to the 7/2. That's a fraction exponent. It doesn't logically make sense. So what do we do with that 5a to the 7/2 on the bottom? Turn it into a root or a radical. Very good. You can call it a root. That's fine. So turn it into a radical. What would the index of the radical need to be? 2, because that's the denominator. That would be on the outside, right? So we know it's going to be a square root. Remember, you don't write the 2 as understood. And then what's going to be on the inside? Yeah, all the rest. 5a raised to the 7. And what I need y'all to remember is the whole thing. 5a is all raised to the 7th power. How do y'all feel with this? Do you feel okay? Y'all gotta be honest with me. If you're not, we can keep doing converting examples. Does everybody feel like they could convert though? Yes, no, yes? Okay. All right, so can I do one where we also have to simplify? All right, let's do it. That's all yeses. So you can also simplify with these. Sorry about the squeaking. Something's wrong with the heat in this room. Like it's usually hot in here and it always squeaks. I don't know why. I told Mr. McDade and he acted like he couldn't hear it. And I was like, boy, I know you hear the squeaking sound. So, I don't know. All right, let's do. Let's do this one right here. This will be a good one. And then I'm going to give y'all one to try. People at home, how we doing?
Good.
Good? All right, there's a couple different ways you can do these. I'll show you both ways. You can pick whatever works for you, okay? First way you can do these is to do what? Who has ideas on what they would want to do first? What you want to do, Jordan? No, say it. Good. Okay, so what he said is you can go ahead and distribute this exponent into everything in the parentheses. You can do that. So if I distribute that in, what would we be left with? What does that equal? Oh, y'all. How do we distribute in exponents? What do I do with my exponents? I add them. I'm so glad we're doing this today because it seems like y'all forgot your exponent rules. And you take one exponent into the other ones. What operation are you doing? There we go, multiplying. So if this 18 has an understood 1, do y'all agree this would just be 18 to the 3 halves? Okay, there we go. They're like, okay. Now, this is where people mess up doing it this way, Jordan. So I want to make sure y'all understand. If you are multiplying 4 by 3 over 2, come to the side and write it if you have to. The 4 is a whole number, so which of these does it multiply by? The 3, not the 2, the 3. So 4 times 3 is 12. 12 over 2 is, so this is a whole 6. So that looks pretty good, right? All right, and then for the y's, if I'm going too fast, y'all let me know. How many y's would be left? What's 6 times 3 divided by 2? Good job. All right, I see this and I'm excited. This boy woke up late. I'm about to make fun of him. Oh my God, go away. All right, I see this and I'm excited. Why do y'all think I'm excited? Jake's like, I don't know, you're a nerd. Who knows? Yeah, okay, good. So look, x to the 6, y to the 9. Those are whole numbers. Do I have to do anything to those? No, they're whole numbers. Only thing we have to change is this 18 to the 3 halves, right? This is about to be a huge number. I should have been nicer and picked something smaller, but it's okay. 18 to the 3 halves. How can I rewrite that so we know what it means? You can't have a fractional exponent, so how can I rewrite it? 18 to the 3rd, and then I heard somebody say take a root of 2, so square root. That's what we just did, right? Did I lose you? Okay, look. Whole number, whole number. Fraction. Denominator is your bad doggy. Where's your bad dog sleep? Outside, so it's a square root. Where's your good dog sleep? Inside, so this is going to be 18 to the 3rd. Now, if the x to the 6th and the y to the 9th are whole numbers, they're on the outside. Very good. All right, so I want y'all to pay good attention. The direction said simplify. So we got to see if we can simplify this radical. So 18 to the 3rd, this is why when I wrote it, I was like, ooh, this is a bad one. I'm going to type it in just so y'all can see. On your test, I will give you calculators, and you can also use Desmos, okay? You type in 18 to the 3rd, 5,832. So we have to simplify the square root of 5,832. Y'all said you were ready to step it up, Evan. Not that much. I should have picked a smaller number. It's okay though. I mean, if you can do this one, you can do any of them. All right, so let's review. We're reviewing from Thursday and Friday. If I want to find the square root of 5,832, you have to try to find the biggest perfect square that'll go into that number, right? Can I use a calculator? Sure. Let me pass them out calculators, my people at home. While I'm pausing y'all, are there any need to see this? So we're trying to figure out the biggest perfect square to go into 5,872. So somebody said it was divisible by 81. Did I type that in right? Oh, 32. And y'all let me type that in wrong. Shaking my head. It's okay. 81 goes into 5,832, right? Okay, I can look at this and go, that's not the biggest. Why do you think I'm saying that? Good. 72 can break down into another perfect square. So Sean, we talked about this yesterday. If it breaks into another perfect square, you didn't find the biggest one. So 72 breaks up into 36 times 2. 36 is a perfect square. That's not the biggest one. We did. Good, Jordan. So Jordan said what I taught them yesterday. I'm going to write this down for y'all. I didn't really teach it to them. I showed them a shortcut, but that's okay. If you can do the square root of 81 times the square root of 72 and get the square root of 5,832, what I showed them yesterday was if 72 breaks up into another perfect square. Sean, do you remember doing this yesterday?
Mm-hmm.
I can take these two and multiply them, and that should tell me what the biggest perfect square is. Does that make sense? Okay, so let's try it. Let's do 81 times 36. 2,916. So let's make sure that that is a perfect square. I'm going to move this so y'all can finish copying if you didn't have it. Do y'all know how to take a square root in a calculator? Okay, let's review. But I'm also I'm going to show y'all how to use Desmos too. Does everybody see right here above the x squared button, there's a little radical? So if you, and it's in blue, so if you hit the blue button and hit that radical, it pops up with a square root. It's okay. So do you see right here above the x squared, there's a little blue radical? Okay, so if you hit the blue button and hit that button, it'll pop up with a radical. Okay? And if you type in 2916, that is a perfect square. So what can we take out? Not a 2. Can't do square root of 2. 54. People at home, you can take out a 54, right? Because we just said 81 times 36 is 2,916. If you take the square root of that, it's a whole 54. So I can take out a 54. What's going to be left? Look at what's not circled.
2.
2. Good, Viti. So this would simplify to 54, x to the 6th, y to the 9th, square root of 2. Who did I lose? I'm going to pause. I'm going to pause the recording too. Who did I lose? So if you go to Desmos.com, when you guys take your test on Thursday, I have it set up so it'll tell me if you leave Canvas, i.e., don't pull up my notes videos on YouTube when you're taking the test because you're going to get a 0, and I'm not that nice. You ain't going to redo it either. Do we understand? I'm a very smart lady. I'm pretty good with technology. I have it set up to notify me if you leave Canvas. The one website it will not notify me that you go to is Desmos, because I'm allowing you to use Desmos. So Desmos.com is an online graphing calculator. You can also do square roots in here if you like this better. So do y'all see this little keypad down here? Oh, y'all can't see it. Let me do this. Y'all see it? So if you hit the keypad, it's got a square root right there. Jordan, you watching, babe? So if you hit the keypad, go right here, there's a square root, and you can also do it right here. I think this is honestly a little faster. Less buttons to hit. All right, what questions were there on this example? I know it was a hard one. No, the numbers will not be that big on your test. That would just be cruel.
Can you make it so I can set the entire page? I can take a picture of it.
The entire page and get a picture of it. Sean, you're going to want to watch the notes video, babe. The part that you missed.
Yeah.
We'll stay on after. But yes, you can get a picture. Just don't get me in it, or I'm going to be mad because I know you're going to put it somewhere. All right, can I give y'all one to try? Okay. Yes. Okay, I'm just making sure.
All right, thank you.
You're welcome. All right, you guys try this one. Let's see. Let's do. God, the numbers are so big. Hang on. I can find one that's not crazy, as I'm not out of the way. I think if I give y'all a number that big again, y'all will be pissed. Okay, this one's not too bad. Let's do this one. You guys try this one. So 27 x to the negative 9th, y to the negative 21st. And I'm actually going to help y'all set it up because I want to show you the second way you could do these. Jordan, let me know if my handwriting gets crazy. I trust you to tell me the truth. Macy, how you doing, girly? Good? Okay. All right, y'all. First way we can do it is the way we just did it, where we carried in the what first? The exponent. So you can distribute your exponent first. Now, I'm going to be honest with y'all. I don't normally do that first. Good. You do have to flip it. Very good. So that's what I normally do first is I flip it if it's negative. But even after that, I'm not going to carry in the 2/3. So let's do that first. Very good, Jordan. So we have to flip it because it's raised to the negative 2/3. So this is going to be 27 x to the negative 9th, y to the negative 21st, raised to the 2/3. Huh? Okay, hang on. You can flip the whole thing because it's all in parentheses to a negative exponent, or you can distribute it first. But you can't just put, if you put the 9 and the 21 in the denominator, the x and the y, then you still have a negative out here. So either way, it's going to get a little messy, okay? All right, once you flip it, let me just show y'all what I do, and you can tell me how I did it instead of carrying in the exponent. So this is what I do. So instead of distributing that fraction, because I'm not always great at multiplying fractions, what did I do?
You put the denominator as the index and you left the 2. I made it positive.
Good. Is this Sean?
Mhm.
Look at him joining late and getting it right. Good job, babe. I'm proud of you. I converted it first. I changed it to a radical first because now we know it's a cubed root. And then look, all you got to do is carry in that 2 to everything, but it's a whole number. It's not a fraction. So if you are not great with multiplying or adding or doing operations with fractions, I want you to convert it first. Does that make sense? Now, if you are totally fine with multiplying in a fraction, you can do it this way. Do we see the difference? It doesn't matter when you multiply because with multiplication, order doesn't matter. So we all should end up with the same thing. Is everybody okay? People at home, y'all are good?
Mhm.
Yeah.
Okay, so can we carry in the 2 exponent into everything now? All right, let's do that. I'm gonna get a different color because I need something else to look at. All right, so this is gonna be 1 over the cubed root 27 squared.
729.
Oh, good. Did you type it in?
Mm-hmm.
Okay, good. Me too, because I didn't know that that was 729. So 27 squared is 729. How many x's do I have now? What kind of 18? There we go. X to the negative 18. And y to the negative 42nd. Very good. So I'm not asking you to finish the whole thing. Can you guys simplify this cubed root for me though? The exponents are negative, so however many you take out, they just have to be what?
Negative.
Negative. Good. Do we understand that?
So whenever you multiply
The 2?
the two to everything else, you add them or you actually multiply?
you're distributing, so you actually multiply. You add your exponents when you're just multiplying two terms. But I want this whole thing squared, which means I'm multiplying it. I have it twice. Good question. All right, listen, this is what I want y'all to do. I'm going to pause the recording so you can feel free to ask questions. Nobody will see it later. We're simplifying this cubed root. So if it's a cubed root, I need you to find the biggest perfect cube that'll go into 729. Okay? You have perfect cubes in your notebook, and then my variables have to come out in groups of 3. Good job. So what I'm noticing, y'all's biggest issue is finding perfect cubes. That's not a hard issue to have. I cannot believe that's what's stumping y'all. That's wild to me, because usually my students get stumped by the fraction part. So if y'all understand that, we're good. I can fix your perfect cube crap, okay? Cubes, think about cubes. I'm gonna come to the side and just write these down again so you guys can understand what I'm doing when I think through this. 3 cubed means 3 times 3 times 3, right? What does that give you? 27. All right, 4 cubed is 64. 4 times 4 times 4. 5 cubed is what? What's 5 times 5 times 5? We wrote it in your notebook last Thursday.
125.
Good, 125. Anybody know what 6 cubed is? 216, and then we didn't get this high, but let's just keep going. 7 cubed is what? 343. You can do 7 times 7 times 7 in a calculator. That's where we're getting these numbers. What's 8 cubed?
512.
Oh, 512. Thanks, sweetie. That's okay. I don't know it either. I don't know it when it gets past 5 usually. And then 9 cubed, if you do 9 times 9 times 9, what do you get?
729.
So what is the cubed root of 729? A whole 9. I did not give you a hard one. The number was kind of large. But go down and find all your perfect cubes real quick. That's what got you. So can I use you as an example in a good way? Let's review what we just talked about on the last one. So Jordan told me that he found out 729 was 27 times 27. So I want y'all to really watch so you can use the shortcut. These are also both perfect cubes, right? So what's the cubed root of 27? 3. Look, 3 cubed is 27, which means the cubed root of 27 has to be 3, right? Means you have 3 3. So everybody look. If this is a whole 3 and this is a whole 3, what is 3 times 3? So the cubed root of 729 should just be 9. I didn't give you a crazy one. I know the number was big. Jake's like, it was crazy. The number is big, but it's a perfect cube. So people at home, do you guys agree with us in class that we can take out a whole 9?
Yes, ma'am.
Okay, how many x's can come out, Haley? If I need groups of
-6.
3. Good, -6, she said. Do y'all agree? If you have 18 x's and you can take them out in groups of 3, that means you can take out 6 groups, right? And it should be negative. All right, if you're lost, you gotta let me know. Some of y'all look confused, but I can't read your mind. I'm smart, not that smart. How many y's, groups of y's, can we take out? Good, -14. Look at y'all. So what's the only thing I have left to do to simplify this? I think you said it. I just couldn't really hear you. Oh, change what to positive? The exponents. So Carter, I think you were talking to me. How do we change these exponents into positive ones?
You gotta move them to the numerator.
Yes, move them to the numerator. So this would be x to the positive 6, y to the positive 14 over 9. How do we feel with this example? Do y'all want, do you want another one? You want me to show you something kind of different now that you have two of these? Talk to me. Something different. They're saying something different. So we have two like this one and the one we did before. Are y'all good if I show you something different? Okay. Let's do this one. So there's really like not a whole lot new to do with these. It's just practice. They take practice. You have to be able to convert them and see your perfect cubes and perfect squares. All right, for this one, all I want you to do is convert back to a rational exponent. I want to see if we can know how to do this before I give you the next one. And then I'll give y'all one more, and then if you want an extra one to try, I'll put one up. If you feel okay, you can start your assignment for today. Y'all have done so good. I'm excited. All right, I want you to turn it back into a fractional exponent. Remember, rational just means ratio, so fraction. So how would we put this as an exponent that's a fraction? 2/3. How'd you get 2/3? Very good. Yeah, the index was your denominator. The exponent inside was your numerator. So he just worked backwards from the rule I showed y'all earlier. Remember, your good dog, the one sleeping inside, that's your top dog. The dog sleeping outside was bad, so he's your second dog. He's on the bottom. That's it. All I said was convert. That's all you had to do. If they ask you to convert it, they just want you to write it back as a fractional exponent. That's it. It is, yes. Converting is easy. They get tricky when I give you something like this and I say simplify. Because if all they said for this one was convert, y'all, we would have been done right here. Because that's where we changed it to a radical. We would have been done. But they said simplify, so then we had to simplify the radical. That's the tricky part. All right, so I want you guys to do this one then. So I want you to, some of y'all about to be mad, simplify. Oh, that was very sloppy. That's a 5th root. It's not a 5 outside. My hand just got excited and I wrote it large. I'm sorry. Let me be a little more careful. I'll do this one with you because y'all are already looking overwhelmed. And off the record, Honors Math 2 is supposed to be challenging. It's my job to get you ready for Honors Math 3, which is pretty hard. I'm going to push y'all. This is my favorite class to teach, though, because you guys come from middle school getting A's on everything because they didn't push you hard. And so while you were like smart, and you're still smart, and you're very intelligent, you didn't have to work hard for it. Now you have to work hard. So I'm going to grow you. All right. What do y'all want to do first?
Convert them.
Okay, I agree. So do you guys notice when we did that last example, if we had distributed the fraction first, it would have gotten kind of crazy off the bat. I recommend, it's just a recommendation because it really doesn't matter because we're multiplying, but I would convert first. Now, I'm going to tell you for this one, you have to convert first because I haven't taught you how to multiply radicals that have different indexes. This is a 5th root, this is a 4th root. Can't put them together. So good, VD, let's convert first. If this is the 5th root of 3, how would I write that with a fractional exponent?
You would do 3, and the 3 has an understood 1, as the exponent, so it would
Uh-huh.
be 3 to the 1/5.
Look at her go. I'm so proud of you. All right, listen to what she said because she explained it just like I would have. The 3 has an understood 1. There's your good dog. He goes on top. The 5th root, that's the index. The 5 goes in the denominator. So this is just 3 to the 1/5. Do we understand that? Okay, good. All right, what about the second one?
35 to the 1/4.
Wait, what'd you say?
35 to the 1/4.
That's an exponent, sorry.
Oh.
I'll be neater. The ADHD has been very real today. I'm just gonna say that. So that's not 35, that's 3 to the 5th. So what would we write to convert it?
3 to the 5/4.
Good. All right. 3 to the 1/5 times 3 to the 5/4. Henry's like, I don't want to do this. He's like, let's stop there. But you can't stop because it said simplify. And we can't just type it in a calculator either. So these exponents should be fractions, not decimals. You put a decimal on your test, I'm not giving you full credit because that means you just typed it in a calculator, which is cheating. Not really, but it's the easy way out. Don't be a chicken. Understand the math behind it, okay? So look, I'm multiplying 2 terms. Oh my God, I'm up here punching correct. 2 terms that have the same bases. What do we do with our exponents when we're multiplying with the same base? Who said that? Good, Henry. Henry, you got like 6 points extra credit today. You add them. People at home, you remember your exponent rules, right? Because they're on this test. I hope so. 2 terms have the same base and you're multiplying, you can add the exponents, right? This is where y'all mess up. This is where I get so sad with the elementary and middle school teachers, but it's okay. You add the exponents. How do you add fractions? Don't nobody say cross multiply. Every year some kid tells me cross multiply and I'm like, what? Yes, good. Common denominator. Like all of them just said that. People at home, y'all agree we got to get a common denominator?
Mm-hmm.
Okay, and I just heard somebody in class say it's 20. Do y'all agree? So look at your denominators. 5 times 4 gives you 20. So if I want to make them both have a denominator of 20, what do I need to do? Oh, good. Okay, so good. He said, and this is what Henry was going to say too, I think. If you want it to be over 20, the 5 has to multiply by 4, which means the 1 has to multiply by 4. So what's the numerator here going to be? 4 over 20. I hope I didn't lose anybody at home. Some of y'all are really quiet. What about the second one? What do we multiply by? Good. 4 times 5 gives me 20. So 5 times 5 is, all right, kiddos, what is 25 plus 4? 29 over 20. So this is just going to be 3 to the 29th over the 20th. Now, depending on how lazy the person who made the test was, if it was me, I was not lazy. This might be an answer choice. But what did I tell you at the very beginning of this whole lesson? Oh, nobody remembers? All right. I'm gonna let y'all in on a secret. Me and Evan grew up 3 houses away from each other. He lives in my parents' neighborhood. Well, I live in a neighborhood that connects to theirs now, so I saw Evan riding his bike like the whole quarantine because we were walking too. If I told Evan to go ride his bike around our neighborhood 29 over 20 times, it doesn't make sense. What did I tell you at the beginning of the lesson? You should not have a what? A fractional exponent. So how do you think your answer choices on the test are going to look? No, not like this. Like what? What were you pointing at? This is a fraction exponent. They ain't going to look like this. It's going to have a root. So Jaden, how do we convert this? Put it back. Top dog, bottom dog. 20th root. So the 29th. And I would never make you do 3 to the